Okay, today we're going to start Chapter 8. And Chapter 8, at the beginning of your notes, you'll notice this quadrilateral flowchart. Now, this quadrilateral flowchart is kind of the thing that's going to guide us through Chapter 8. And I'll give you an example. We start right here with just a regular quadrilateral, something with four sides. And then the next section we move down the flowchart, and when I say move down, I mean we take this regular quadrilateral, something that has no special characteristics. It just has four sides, four random sides, none of them being the same length, no angles that are special, nothing like that. And we move into something called a parallelogram, and when we move down the flowchart, we add properties, meaning this quadrilateral has a lot of properties to it that we're going to find. And then you'll notice from this parallelogram, we can actually move left to what's called a rectangle, or we can move right to something called a rhombus. And then you'll notice the flowchart actually gets smaller again to something called a square. At the very top, you'll also notice that instead of going to a parallelogram, you could go to left to a trapezoid, and trapezoids have different properties than parallelograms. Or starting with a regular quadrilateral, you could move to something called a kite. And a kite has different properties than a parallelogram and a trapezoid. So what you'll see is as we move down, we're going to use this first page as kind of a guide to write down new properties next to each new quadrilateral. And the reason we want to do this is you're eventually going to be asked what quadrilateral has these properties, and you're going to have to say, oh, it's a rectangle. Or you might be told this shape is a trapezoid. And the moment somebody tells you that it's a trapezoid, you need to be able to look and see, oh, because it's a trapezoid, it has all these principles. The top and the bottom are parallel. The consecutive interior angles are supplementary. The diagonals are congruent, stuff like that. And we're going to find out what all those characteristics and properties are. But today what we're going to deal with is just a basic quadrilateral. Now go to the first page or the next page, and we start in section 1 dealing with the angle measures inside polygons. And before we can get to the angle measures, there's something that we need to go over called diagonals. And a diagonal is simply a line segment that connects two vertices. A vertice is a special word for an angle. If you take any angle or any two angles and you connect them with a line segment. Let's say you take B and E, and you draw a line segment there. That is called a diagonal. Let's say that you take D and A, and you go from A to D or D to A. That is also a diagonal. And again, a diagonal is just a segment that joins two angles. We're also going to talk about the interior angles of quadrilaterals, or generally polygons. Now, let's talk about the word polygons. Poly means many. Gon is just a word for a geometric segment. So this is many segments, meaning many sides. Now, specifically, we can name special polygons. You all know what a triangle is. Tri has the prefix of 3, and then angles, well, that tells you that it has 3 angles, really not that hard. What we can do, though, is based on the number of sides, or any number of sides a polygon has, we can figure out what the sum of the measures of the interior angles are. Meaning, what does the total interior angles, or what do the total interior angles add up to be? Now, this isn't that hard. You've already been exposed to something like this when you deal with a triangle. The inside of a triangle adds up to how much? Most of you are already saying it in your head, it's 180 degrees. You already knew that. You already knew that if you take the 3 sides of a triangle and flatten it out, you get 180 degrees, you get a straight line. But what we're going to find out is the more sides that you add, like let's say you go from a triangle to a quadrilateral, okay, 4 sides, we find out that it has more than 180. In fact, we can take any quadrilateral, break it up into 2 triangles, which means that the interior angles have just now doubled. But what we're given in geometry is a formula that tells us if you take any number of sides of a polygon, let's say it's 6, you could plug 6 into this equation, n minus 2 times 180, and you can find out what the interior of any polygon is, whether it has 3 sides, 4 sides, 5 sides, 100 sides. You can plug in the number of sides into this formula and find out what the interior of the shape or the polygon adds up to be. And we're going to find out why that's important in the next page. But aside from that, you're also told this: the sum of the measures of the interior angles of a quadrilateral is 360. You already knew that. We knew that any quadrilateral, whether it's a square or a rectangle or a trapezoid, you can, in any one of these, you can randomly cut it into 2 triangles. And because it's 2 triangles, it has 2 180-degree measures, which means 360 degrees. This corollary is just telling you, if you know something has 4 sides, don't bother using this formula. You can just always guarantee it has 360, just like a triangle. We don't plug in 3 when we want to know how many angles or what the total of a triangle adds up to be. We just already know that it's 180. From now on, know that a quadrilateral has 360 degrees. So this formula to find the interior angles of a quadrilateral, we're going to use that on the next page to go through the different types of polygons you're going to be exposed to. So go ahead and turn the page. Here we see in example 1, we're told to find the sum of the measure of the interior angles of a convex, and then we have pentagon, hexagon, octagon, nonagon. Now, you're going to need to know different prefixes, meaning words that are used to describe a specific number. You already know, bi, okay? Bi is a prefix to determine 2, whether it's bicycle, okay? Bicameral, something that has 2 cams, like a bow or a car engine. Then we have the prefix tri. And tri, you already know, with tricycle and triangle, is 3. Then we have quad, and some of you already know this because you have ridden quads. A quad has 4 wheels. A quadrilateral has 4 sides. Then we go to penta. And some of you are already familiar with penta because of the Pentagon in Washington, D.C. The Pentagon has 5 sides. Then we have hexa, which is 6. We have hepta with a P, which is 7. We have octa. Whoops, I don't know why I made that a Q. Octa, which is 8. Nona, which is 9. Deca, which is 10. Really, these are the only ones that I require you to know, and bi really doesn't matter because you really never have a biagon. You can't make a geometric shape with 2 sides. It's physically impossible. It has to have at least 3. The only other one that I'm going to require you to know on a quiz or a test, but I will also remind you of it, is something called a dodecagon. And this has 12 sides. The rest of these, from 3 to 10, I do require you to memorize, especially for quizzes and tests. And you'll see why. As in example 1, you need to know them. Let's say you were looking for the interior angles of a pentagon. Now, a pentagon, you should already know, being as we just talked about it, has 5 sides. What I'm immediately going to do is plug 5 into my formula, n minus 2 times 180. And so I have the problem. Make sure you're writing this down, too. Don't just take it for granted like, oh, I can figure that out. Because it does get harder as we move along. Once you have this down, it's simple math. In fact, you can plug this entire sentence on your calculator. We get 5 minus 2, which is 3, times 180, which is 540 degrees. So the interior of a pentagon, something with 5 sides, adds up to 540. A hexagon, again, we just went over it, it has 6 sides. So again, I use the formula n minus 2 times 180. I plug in my 6. And what I find is when I take 6 minus 2 times 180, I get 720 degrees. What I'd like you to do now is solve for the interior measures of an octagon and a nonagon. Pause the video and do that now. Okay, hopefully those problems weren't too tough. An octagon, something with 8 sides, we take 8 and plug it into the formula n minus 2 times 180. And what we get is 1,080 degrees. Remember, this is what the interior of an octagon adds up to be. If I quickly draw an octagon for you, the interior of an octagon adds up to 1,080 degrees. Then we do the same thing with a nonagon, something with 9 sides. Excuse me. We take 9 minus 2 times 180 and we get 1260. Now there's a little note here, and I want you to think about this before you just answer. If the polygon is regular, regular meaning all of the sides and all of the angles are congruent, could you find the measure of each interior angle? You know what they all add up to be, but could you find the measure of each interior angle? And the question is, or the answer is yes. If we redraw our octagon, octagon very quickly, we know that all of them add up to 180. Okay, we just figured that out here in letter C. Well, there are 8 angles. And because it's regular, all of those angles are congruent, which means that I can actually do this. I can shove the same variable into all of them. And when I add them all up, they should equal 1,080. So what I get is the problem 8x equals 1080. Not 10 comma 80, but 1,080. Well, when I solve this and I divide by 8, I find each interior angle to be 200, and let me finish punching it in my calculator, to be 135 degrees. You can take the interior angles, as long as the shape is regular, meaning all the angles are the same. You can take all the angles, the sum, and divide it by the number of sides, and you find the measure of each interior angle. Hopefully that makes sense. Let's look at example 2. Example 2 tells me that the sum of the measure of the interior angles of a regular convex polygon is 900. I want you to think about this, because this is telling me the answer to my problem is 900. Then it says classify the polygon by the number of sides and find the measure of each angle. This problem is asking for, what is this shape called? Well, you can't tell what it's called until you figure out how many sides it has. That's what we're looking for. We can take the formula n minus 2 times 180, which gives me the interior angle sum. Well, they just told me the interior angle sum is 900, which means it equals 900. Whoops, don't do that. So I can take this problem and solve for n, the number of sides. So if you look at this problem, and using our algebra skills, the first thing we need to get rid of is this 180. We need to get rid of it because we want the n minus 2 by itself. So I'm going to divide both sides by 180. And what I get is n minus 2 equals 5. Now I'm not done yet. I can't say what I have as a pentagon because I still need to solve for n here. The way I solve for n is by adding 2 to both sides. What I get when I do that is n equals 7. Now the question is, classify the polygon by the number of sides. What's something with 7 sides called? And all you have to do is look at the very top of our notes to figure out that it is a heptagon. And then it says, find the measure of each angle. Now this is something we just discussed in the note. If the total interior angles add up to 900 degrees, and there are 7 equal angles, I can write the problem like this. 7 times each interior angle equals 900. If I divide both sides by 7, I find out that each interior angle equals 900 divided by 7, and I get each to be 128.57 degrees. Now I hope that makes sense, and I hope that's not too complicated. Let's look at this page once again, because you have to, this is a good reflection of what you're going to be doing tonight on your homework. You're going to have some problems where you're told to find the sum of the measure of the interior angles. You're going to have some problems where they give you the sum and ask for the number of sides, and maybe even ask you to name it. and then some that ask you for each individual angle, which is what we did here. Go ahead and turn to the next page and you're going to see a guided practice problem. Pause video, erase previous statement. Go to the next page and you'll see two more problems. In Theorem 8.2, the exterior angle theorem, if you take any shape, or any polygon, okay, here we have a quadrilateral, and what this theorem says is if you extend the sides to form straight lines, then we tie in an idea that you've already been dealing with all year long. You bring in the idea that exterior angles form straight lines, and a straight line equals 180 degrees. Which means, if you think about each of these angles, like this, we'll call this one x for now. X plus this exterior angle form a straight line. Well, if a straight line is 180, then you can say this angle plus 1 equals 180 degrees. What this tells you is the sum of the measures of the exterior angles of a convex polygon. Convex polygon meaning any number of sides. Something that has 10 sides or something that has 4 sides. All 4 of these exterior angles are going to add up and equal 360 degrees. If I draw a quick, let's call it a hexagon, something with 6 sides. If I draw a quick hexagon, and I take all of these lines, or all of these sides, and I draw straight lines out of them. Call that 1, 2, 3, 4, 5, and last but not least 6. All of these exterior angles have to add up to 360 degrees. It doesn't matter if the shape has 6 sides. It doesn't matter if it has 4 sides. The exterior angles always add up to 360 degrees. Not too confusing. It's just something that you need to get used to. A simple statement, just like a supplementary angles always add up to 180. Exterior angles of any convex polygon equals 360. Let's take that and apply it in example 3. It says find the exterior measure of each angle, meaning we have to find each individual angle, of this convex polygon. Well, like we just got done discussing, it does not matter how many number of sides this shape has. The exterior angles have to equal how much? The correct answer is 360. Well, now what we can say is this angle plus this angle plus this angle plus this angle plus this angle equals 360. So I can say 4x plus 4x plus 4x plus 4x plus 4x equals 180. There are 5 of them. Well, when you add 5 4x's, you get 20x equals 360. Divide both sides by 20. You get x equals 18. So I know that x equals 18, but that doesn't tell me each angle measure because each angle is 4x. So I take my 4x, substitute my 18 in, and what I find is that each individual angle is 72 degrees. Let's back up and let's remember that we took all of the exterior angles and said they have to equal 360. All 5 exterior angles add up to 360. Well, then we solve for x, plug that into our angle because we want to know what each individual angle is, and we find out it's 72. Now, if you think about it, or I'm telling you this is where your homework assignments are going to go, because you know the exterior angle is 72 degrees, could you figure out the interior angle? Now I'm going to ask you, why can you figure out the interior angle if you are only given the exterior angle? What do the exterior and the interior add up to be? The answer is 180 degrees. If the exterior angle is 72, then the interior angle is 180 minus 72. or in this case, 108? Well, if you were to figure out that this interior angle is 108, well, maybe you could use that to solve for the other ones. Go to the next page, and now we see 4 guided practice problems dealing with 4 different shapes and solving for different pieces. You'll notice in number 1, you have to solve for an interior angle. Number 3, they're asking you to solve for an exterior angle. Number 4 and number 2 are similar to number 1 in that you have to solve for an interior angle. Remember the difference. What does an interior angle add up to be? What does an exterior angle add up to be? Are either of them dependent on the number of sides of the shape? What I'd like you to do is pause the video, review your notes, and I would like you to go through and solve these 4 problems now, and then when you're ready, hit play and we'll go over the correct answers together. Okay, just like last chapter with sine, cosine, and tangent, these problems can take a while, but they are by no means hard. They are very simple algebraically and geometrically, and you'll see that as we go through them. Now, if you got them wrong, not a big deal. We make simple mistakes sometimes when we're solving big problems. All you have to do is just look at the algebra and see where you made a simple algebraic mistake. It could be something as simple as just writing down the number wrong. But you'll see that this first problem, I started off by saying it has 4 sides, which means the interior adds up to 360. And then I actually wrote a statement where all 4 angles equal 360. When I do that, I get 277 plus x equals 360. Subtract 277, you get x equals 83 degrees. The second problem, I started off by saying it has 5 sides, which means the interior angle theorem interior angle theorem determines that it equals 540. And we do that by saying n minus 2 times 180. Plug in 5. We get 3 times 180, which gives me 540. Then you can see that we started off writing our sentence. 5x plus 139 plus 9x plus 71 plus 92 should add up to 540. We combine our like terms to get 14x plus 302 equals 540. We subtract 302, then divide by 14, and we get x equals 17. You go down to number 3. Now number 3 is different than the other ones because it deals with exterior angles. So I started over here by saying exterior angles equal 360. Then I come over here and I write all my exterior angles, add them up and make it equal 360. Combine my like terms to get 150 equals 7x, or plus 7x equals 360. We subtract 150, then divide by 7, and we get x equals 30. Now the fourth problem is a little bit longer, but we can just look at the thought process, the steps to solve it. We start off by saying it has 7 sides. When I use the same interior angle theorem that I used in number 2, I find out that a 7-sided object, the interior angles add up to 900. Then I actually went through in this step and actually wrote down all the angles, added them together, make it equal 900. Now, because of the lack of space, I solved this one on a different piece of paper. You combine your like terms. Your like terms are 102, 124, 146, 158, and you end up adding all those to equal 530. Then you add up your 24x, your 34x, and your 16x, and you get 74. Well, when you subtract 530 from 900, you get 370, and you end up getting 74x equals 370, divide by 74, and you get x equals 5. Now, the geometry statements, okay? If we look at these, let me highlight them so you can see. That's a geometry statement. That's a geometry statement. That's a geometry statement. That's a geometry statement. If you understand where we got those and how to find those on your own, you're well on your way to making this chapter one of the easiest chapters that you'll see this year. Aside from chapter 9, the rest of the chapters are very simple, meaning 8, 10, and 11 are very simple. This chapter, it doesn't get much different than this right here. Very simple geometric statements that if you can set up yourself, know where we got it, know how to find it yourself, and solve it accurately, you're going to blow this chapter away. Okay? But let's go ahead and take a look at what we learned and apply it for your homework tonight.